Welcome to today's class. It's not going to be too long. It's um, it's not going to be too long, and I welcome you all once again. So today we are going to be talking on the topic tools any data scientist should know. It's basically six tools we are going to discuss. They are not tools. There are six categories of tools we are going to look at, and under those six categories we are going to see the various tools that are under it. The categories like the family name, then the tools under it are like your first name. All right, so we're going to touch some. We won't touch all the tools because there are enormous numbers of tools, quite enormous. So we are going to touch some. When you will hear about this one, you have an idea of the others tools that are in that category. You understand? So I just want you to relax, sit down, take a hot cup of tea, and get your jotting materials, and let's start the ride. So we are from Southgate DataNet, and this is our let me increase the screen. Our website. This is our website. We are a technology company in Lagos, Nigeria, and part of our website is sgdatanet.ng. All right, that's who we are, and these are some of the things we do. We help in implementing, modeling, and designing IT solutions. Whether it's a software, whether it's an application, we help in that area as long as it's something a software can build. Or yes, we are there for you. We also help in consulting on business end-to-end solution in the business intelligence space. Business intelligence space, in the data analytics space, in the research space. We are there for you. And another thing we do is even if your organization wants to, they don't know what they want, but they want to be better. They want to improve employee performance. They want to improve sales. They want to improve productivity. They want to improve their services. You need a business intelligence expert that can come, look at your processes, look at your data, sit down with your staff, get how the processes work end to end. Then you can be able to use your data and be able to give solutions to what he thinks your business needs to be focusing on, or stop doing, or start doing. All right, and the last point here is training, mentoring, and coaching. Whether the BI there means business intelligence, BA means business analyst, DS means data science, then the DBA means database administrator. So if you fall into any of this category, you are good to go. We are there to help you. We are there to train you. We are there to mentor you. Our training doesn't stop when your money stops. No. Our training stops maybe when you become a coach. You understand? So it's not that when your money stops, your training stops. No, it's not like that. Your training is forever. We believe that mentoring is a lifelong journey. Just like we have mentors in the world, we have mentees and people that we mentor, even in the data science space, in the BI space, because we have been in the business for a while. We know the pitfalls. We know what we think. Over years we've gathered experience, and we know some of the things you might need to know that will make you move faster in your career. Some of the certifications that you need to do, some of the certifications you don't need to do. Don't waste your money on. We have an idea of those things because we've been through that phase in our own life too. All right, okay, and those are our social media handles. So if you're not following us, follow us on Facebook. That's our email. We are on Instagram to southgate.ng. Follow us. Thank you. So let's start with a big word, which is data scientist. All right. So everybody talks about data scientists. What do they do? What are they called, data scientists? All that. The thing there is, data scientists, anybody that gets a job, you are there to solve problems. Data scientists are also there to solve problem for their organization. the organization, either they want their revenue to increase. It's a problem. You are there as a data scientist to solve their problem. You know, whether you are there, they want to, and the kind of problem a company have will be peculiar to them. A company might be, oh, we want to push our product. Our product is doing well in this region. We want to make it do well in this region. That is a problem for that organization. So a company, they want their services to be well known, to be well appreciated. That is a problem. So you are there as a data scientist to solve problem, and when you solve problem, you create impact in that organization. You create insights, and some of the problem you solve might be product recommendation. And I'm sure all of us are working somewhere, and there are challenges or there are goals, there are targets that organization wants to meet, and you can name some yourself. We believe that with data you are able to solve most of these problems. Not all the problems the organization we're facing, but most of the problems can be solved with data. All right, so what are the tools? I told you we are going to talk about 6. So these are the 6 tools we are going to talk about. They are very, very important to pay attention now. Please, I want you to pay attention. These are the tools. The reason why I'm taking time, not moving the slide so fast, because I want you to jot. And if you have questions, you can ask. You can just ask me. You can just say something, and I will give you the opportunity to express yourself and ask the question. So we are going to look at these various tools: spreadsheets, databases, self-service data visualization, programming languages, big data tools, and cloud infrastructure. IT infrastructure, which is the cloud. You understand? A lot of all these tools are mentioned there, we are familiar with, but we don't know that in some of the tools a data scientist use, data analyst, data engineer, whatever cap you give it, they use these tools. All right. So what are spreadsheets? What are spreadsheets? Spreadsheets, the ones we all know, we grew up to know, was Microsoft Excel, right? Then Microsoft spreadsheets are just there for data collection. You know, they really don't. How many of us have used Excel before? Microsoft Excel. How many of us have used Microsoft Excel before? I'm sure we have all, right? So spreadsheets are just for data collection. They are very popular. Like yes, but you know, Excel is peculiar because it has so many tools associated with it. Excel has Power Query, you can use formulas and all that, you know, and it must be on your own laptop. But the thing there is, every Excel is very powerful. You know, a lot of companies, that's what they use for their own data analysis from A to Z. That's what they use, and it's a very powerful software, you know, and it has so many tools that are on it. You know, when you put on Excel, you see many tools on it. You know, so what makes Excel a data science tool is because it's basically for data capturing. You know, it has rows and columns, isn't it? It has several rows and several columns, and it's in those rows there are various information stored in it. So that is what Excel is used for data capture. If you are able to use Excel very well, you are able to use it to capture data. You can just tell them capture the information in Excel and send it to me. You can save it in any format. You can save it in any, whether as CSV, whether as XLX, you know. So it's a very vast and reliable, and you don't need to have an interface. You know, if it's not a website that you start entering information and that website is storing it somewhere. Excel, you are just entering it direct. There's no need for a GUI. There's no need for an interface. That is why it is straight to the point. Straight to the point. You are just entering the data direct. Then the other one is Google Sheets. Google Sheets is the screen I put here. It's from Google. It does the same thing as an Excel, but the good thing about Google Sheet is that it is online. It's on the cloud, so you can collaborate. What I mean by collaborate is you can share. You can see the share button here. It means when you click the share, whoever you are sharing the information to, have access to edit it, have access to do all sort of things on the Excel or the Google sheet you have sent. Very good for collaboration. It's centralized. You can share. It's not just on your laptop. All you need to do is for your organization to have an account, a business account. And if it's a personal account, you can use Google Sheets. If it's a business account your organization set up, then everybody can collaborate using the Google Sheet. Do we get the point now? Do we know the difference between Microsoft Excel and Google Sheet now? They do the same thing, but Excel is on locally on your laptop or your desktop, while Google Sheet is on the cloud, and it's for capturing information basically. Am I too fast? Are we getting it? Hello, are we there? Hello, can you hear me? Is anybody there? Okay, you can hear me. Okay, good. So that's that about the Google Sheet. The next one is database. Database. We've been hearing database. Everywhere you hear database. Even those that don't know the meaning of database use it. They don't know how it works. They use it. They mention it. They talk about it. I'm sure in a week you must hear the word database. Alright, so there are different categories of database. Database basically are not too good for analysis, and I will tell you why. But they are good for something, which is for storing information. So when you have for storage, and storing transactions. So if you have a website and there are transactions happening on the website, those transactions are stored automatically on the database, because your web page will capture the information and store it in the database. All right. So before you can, and there are different categories of database. We have relational database, which is the Oracle. Example of relational database are the Oracle, SQL Server, and Microsoft Access. There are other types of database, which are column database, document database, graph database. Column database are when your records are stored in columns. Document database is like document management system, and the graph database is when your database are stored as the graphical entities, where how graphs looks. That is how that database will look. Alright, but if you are going to be working with database as a DBA, you need to know SQL. The language you use to talk with database is called SQL. So if you want to get information out from the database, you write some SQL query and it fetches the information out for you. And database store structured data. Structured in the sense that we have columns and we have rows. We have what should be in each row. You can't put numbers where alphabets are supposed to be. So that's why we call it structures. You can't put alphabets where numbers are supposed to be. Like a place for sex, is either male or female. You can't type 1 2 3 there. That is why we call it. It's well structured. Databases are well structured. They are well planned. As a DBA, as a data analyst, you need to know these two very well, because if your data are on a database and you want to analyze it, first of all you need to get the data out, export the data out. And if you don't know SQL, if you don't know how to even build a database, how to model a database, how to design your database, it will be difficult for you to operate as a data scientist, because you are working with data, and these are very, very key components you need to pay attention to. You need to know the language. You need to know how to design a database, how to model a database, how to create relationship between your various database and various tables, how to get the information out when you need, how to update the database, how to delete records in the database, how to save information into the database, create record and all that, delete record, update record. You need to know all these fundamental, we call them the fundamentals of database. If you are coming out fresh into data science or big data, whatever, these are some of the things. If you have decided that I want to be working with data, you must know this very well. The one I mentioned earlier, it's very important too, spreadsheets. You must know how to use spreadsheet. There are so many things that could save you stress if you know how to use spreadsheet, and there are so many things that will save you stress if you know how to use database. So those are some of the things I just want you to pay attention to. Then the third tool is called self-service data visualization. All right, so what are these self-service data visualization? As a data scientist, when you have done all your research, you have come out, you have your hypothesis, there's a problem the company is looking at, you have given them a solution, you have given them a recommendation. For you to present it to the management, for you to present it to those decision makers, it has to be in form of visuals, something that shows charts, graph, line graph, bar chart, gauges, KPIs. Those are, because management want to see the figures, want to see the diagram. They don't want to see a long report that they'll be reading. They'll have to be opening book, reading page 1, page 2. No. They just want a graphical view of what you have done, what you are proposing. And the tools you use to do that are called data visualization. So you can see that everything fits into each other as I'm talking. You can see, so some of the those data visualization are very easy to use. This self-service visualization, they are very easy to use. Some of them are free, and some of them are just as easy as to use. Even easier, some of the things you will do on these data visualization tools are easier than Excel in some places. In Excel, some places you need to start typing formulas and all that, but with this tool, it makes things easy. That's why they call them self-service. And I'm going to pick them one after the other and explain the benefit of these tools to us, so that we will know, okay, if this is what I like, I need to focus attention on it. You understand? Alright, so the first one I have there is Tableau. Tableau happen to be one of the first players in data visualization. They came into the game early, maybe 10 years ago or so. They've been in the business for a while, and it was because of them that all these other players came in. All right, so but theirs is not they have a free version, but they charge also. It's not totally free. The student version is the free one, but if you want to use it that student version has limited things it can do. You can't compare it to the premium version. So they've been in the game for a while. Power BI is from Microsoft. It is also very easy to use, and very, very easy to use. ClickSense came also. Then they are also, all of them are also very easy to use. So what you do is you download these softwares and you install them on your laptop. Power BI is free. You can download it on your laptop, and if you have data, you load data into it and start analyzing your data with it and create visualization with it. But all these tools that I say they are free, they also have their premium version. Like Power BI is free. The Power BI desktop is free. You can download it now on your laptop and install it straight away. But there is a premium version that you use on the cloud, which allows a lot of people to collaborate. You can share your visuals with your colleague. You can share your visuals you can send it as reports to the phone of your MD, or as an alert that automatically sends every month, every week, things like that. You can schedule the reports. And then the last one, the AWS, that is Amazon Web Service QuickSight. Amazon Web Service QuickSight, they are the deal breaker. You know why? Their own, you don't need to download. You just need to create an account on their website. Their own is based on the cloud. It means you don't need to download anything. You just need to create an account. When you create an account, you are able to use the service. You can use it. Everybody can use it. But when things are free like that, it means you'll be limited with things you can do. So, but it is very fantastic. It's a good place to also start if you are considering collaborating straight up. If you want everybody in your organization to collaborate straight up without paying a dollar, Amazon Web Service, AWS, is a good way to go also. So those are the story about the visualization. So the other one I want us to look at is the programming. There's no way you'll be a data scientist without having knowledge of programming. I'm not saying these are the only programming language that a data scientist use, but when it comes to analyzing data easily, faster, and things are easier because there are libraries and packages in this language that are tailored for data analysis. That is why you see a lot of programmers talking about data Python, talking about R, talking about MATLAB, talking about SPSS. Alright, so this programming language is R. It's a statistical programming languages, and it's very easy to use. It's open source. It is very fantastic, easier to you write few lines of code and you do much. Python too is another one. Python is a general programming language. You can use it to build websites, you can use it to build robotics, you can use it to build games, you can even use it to build so many things. But it also has a part of it for data analysis. It has some libraries that are built into Python that allows you to use it for data analysis. So you will see some data scientists saying R is better, Python is better, R is better, Python is better. It depends on you. If you are able, but R is just only for analysis. It doesn't do any other thing. You can't use R to build websites. You can't need R to build computer games. You can't use R to build robotics. It is strictly for data analysis. Alright. Then there are other ones that are not free. Like there's a software called SPSS. There's a software called SAS. And like that. Those ones are very good softwares, but they are not free. You need to pay for a license. And those licenses don't come cheap, but they are fantastic. And if your organization is using it, good. But if your organization doesn't want to spend money, you can recommend any of these two. They are good to go anytime. The big data tools. Whoa, I love this part. Big data, big data, big data, big data, big data, big data. Everybody talks about big data now, but I'm just going to give you a definition that will blow your mind. You see, I'm not going to give you one big definition that will go and check Wikipedia. Just look at big data as data that is too big for your laptop, your own laptop. Data that is too big for your laptop to process. Do you get it? Any data that is too big that you can't accommodate, your laptop cannot accommodate it. Any data that is too big that your laptop processor cannot, that when you put on your laptop and load that data, your laptop will just crash. Then it is big data to you. Do you get it? It is big data to you. So this big data, there are various tools we can use for big data. There is Hadoop, and Data Lake is an Spark. There are so many other ones, but these are free ones, that you can get your hands on. So how do they work naturally? Big data means you have a lot of data now. You now split that data into different modules, into different parts. You now load that data on different servers. So there may be a server in Australia, there may be a server in Lagos, there may be a server in Cameroon. You have the data divided into 3 parts. You now load the 3 parts in all those servers. And all those servers, you network them, you connect them in such a way that they now act as one computer. You see the logic? You have 3 servers in 3 different locations. You now program it in such a way that they act just like one. So when you put on one, the other 3 are on. When you send a command to one, it is being replicated in the other. When you request for something, they all gather it from their own and report to you as one. That is the idea behind big data. They are parallel, they are arranged parallel, so they function as one. They can be 10. A lot of times when we are on social media, you might not know which server your phone is picking your profile from. The server you might be picking from might not be one server. It could be a combination of different servers presenting to you content on your Facebook, presenting to you content on your Instagram, but it is very fast. You won't even see the difference, you won't know the difference. And if one server fails, you won't even know that the server has failed, because the other server has the same information like the first server. That is why big data is very fantastic technology, and these tools are very good. Hadoop, wonderful. Spark, wonderful. They are very. Then one thing is, a lot of companies, yes, a lot of companies have started implementing big data technology as one of their products. Like Microsoft, they have their own big data technology. They call Azure, Azure. Then IBM too have IBM Insights. Then Cloudera, they have their own. So Oracle has their own big data infrastructure. So what this company have done is they have created a niche for themselves also, so that they are a player in the big data space. You see, one thing about big data is it is always advisable to use all those big players, because they have the infrastructure to take care of it for you. That's just the truth. They have the infrastructure. You can't have 3 servers. You won't be able to maintain the cost. So it is always good to go with a vendor, than trying to set it up on your own. When you go with a vendor, you get the support, you get the assistance, you get the updates, you get the security. You just need to manage it, you just need to operate it, but you get all the added values. That is why it is always good to go with those vendors. All right, do you have an idea of what big data does now? This is just a tip of the iceberg. It is not the whole lecture on big data. Big data, as I've explained, is data too big for your laptop to process, your processor to process, your memory to process, and you decide to use the cloud. But there are a lot of architecture involved. There are a lot of players that are involved. That is big data for you. All right. Then cloud, the last two. I mentioned big data. I just wanted us to know about cloud also. This cloud basically is IT. You see, all these people names I've listed here, they are more than this anyway, but I've listed some players. All these people are cloud providers. AWS is Amazon Web Service. Microsoft Azure is another cloud provider. Google Platform is there. There are so many. They are just cloud providers. All these guys, you see them there. They are cloud providers. And what they do is they provide you pay as you go. As you know, it depends on the space you are using, depends on the components you are using. Then you can scale it up if you want to scale it down. Then they've made a business out of this cloud stuff. Even there are exams and certifications that you can think of doing from these people. Then they have some components that they have, if you want to go into big data, they have so many components in their cloud system that they can even provide you database. They can provide you everything. You pay for the one you think you need. So that is the fantastic thing about cloud services. So before we go on, I just want to show you I want a data science website called Kaggle before we come to question and answer. So I was mentioning earlier that when it comes to data science, there is always a problem that they need to solve. So this is Kaggle. Kaggle is Kaggle. I have my login. You can go and create your login. So here, all these are problems that is a competition. You can see the price allocation to the competition: $50,000, $50,000, $25,000, $25,000. A lot of data scientists and programmers are seeing this at the same time. But look at one of them. Let me look for one. All right, so see this one. M5, forecast forecasting accuracy. There is a problem here, and you see the way the problem is. The problem is estimate the unit sales of Walmart retail goods. Just, and this is the breakdown of the problem. You have to read this and get the data set and be able to solve this problem. You join the competition, so you can see how data science problems come in play. So it's not that all the skills you learn, you are just to learn them. No, you have to be able to use them and apply them to solve problem. Do you get it? So there's a part 2 of this class, which is this data science problem I solved. There's a data science problem, actually it's from IBM, and it has been solved, and I wanted us to go through it. But before we go through it, I want to ask if you have any question before we move on. Do you have any question? Anything that I didn't explain clearly? Anything you want me to explain better? Let me know. So the floor is open. You can ask your question. Let me know if you have question. Does anybody have a question? Does anybody have a question? Okay, no question for now. All right. Okay, so we go to the part 2. This part 2 is solving a problem. Nobody will come to you and tell you, I want you to solve this problem using data science. No, there's just a problem that needs to be solved. All right. Whatever tool you use is your business. They don't care what tool you use. You are just to give them solution. All right. So this one is the topic is data science and analytics skill overview, how it works. Then the key message is using data science to identify patterns in asthma attack and saving millions of dollars and unnecessary suffering. All right. So let me just give you a background. There was a woman. She works in a company. She's a bioscientist. She's a data scientist also. But it has been noted that people rush to the asthma. This is about asthma patients. Asthma patients normally rush. They have crisis once in a while, and they rush to the hospital. So what this problem is trying to solve is, how do we prevent them from having this crisis, and it's when they have crisis we rush them to hospital. In period of crisis, you can't really tell whether the patient will survive it or not. A lot of people don't survive their crisis. But what if there are signs, there are alerts that it can be triggered if the person is supposed to have a crisis? So we are looking at preventive mode right now. So the person involved was Sophia. She's a data scientist. She's working in biomedical research. She's been working on a project involving weather and pollen, a known asthma trigger. Alright, so this woman discovered that whenever there is a weather change, there is a probability for asthma patients to have asthma trigger. Alright, so what Sophia did was, if there's a weather change, as I said earlier, so there's high risk of attack. That's point 2. So the solution are the ones in green. So the solution was to research for an application that could serve as an alert service. So what that point 3 is telling us, that our goal is to get a lot of data from the hospital, from the internet, and the aim is to produce a product that can send alert to the patient before the crisis starts. Just like you get alert, for alert is notifying you. All right. So what Sophia in point 4, so what Sophia did was, she involved another data engineer to help her. They get some medical records, they got some research records, they got records based on asthma emergencies, and they also got external weather change and pollution records. All these records, they may not be in their domain, so they need to go extra mile to get all these records. All right. So after getting the record, they clean it, they process the data. The data will not be well organized. They clean it. They call that cleaning of data is called data wrangling. Then they do some data exploration to see if if pollen outbreak causes asthma attack. Then point 5, they now develop a model. A model is a miniature program. It's a sample, right? If you want to build a house, you have an architect designs a house. Those small houses you see that they carry to the meeting is called a model. So in data science, you can build a model also. Then you test, but the difference between that one is that this your model is almost like the real thing, but you test it. It's not a caricature like that in data science. So they test that model. So the hypothesis, I forgot to mention hypothesis. Hypothesis is a lot of asthma patients come during crisis. How do we resolve that? That's the hypothesis. That's the problem. So the problem is your hypothesis in data science. All right. So they test their model. After building the model, so Sophia is now qualified that specific point 6. I'm on point 6 now. So Sophia has now determined that weather conditions are strongly tied to onset of severe asthma attack, and now she has created a model to accurately predict the condition. She can now deploy it to create an alert application that will benefit the patient and businesses. She has tested the model and seen that when there's a change of weather, there's a crisis for some asthma patients. She has now tested it. So after doing that, she gives the model to the software developers to build an app. Those software developers build an app, and they are able, that app, they now tell all the asthma patients to download the app. So that is the product that has finally come out after their research. You can see the product is the app. So some of the things there, I've explained model, I've explained testing, I've explained what a data engineer does. They help in cleaning. Then developers are the one that develop the app. Then APIs. API is what connects data to the app. You can fetch data from one place to another using API. Then data science, data analytics. A lot of people get confused that about this definition, but to me, just look at it as the scope of what they do. Data scientist does more than data analytics. The scope of what data scientist does is quite more than what a data analytics does. Then the tools they use are almost similar. They have some similar tools, they have some tools that are not similar. All right. So questions: can data science help make impact like insight, data, product, service, and recommendation? Yes. So that is how a data science problem comes. This is how you break it down step by step, and this is how you come out with a result, with your product, with a whatever you are trying to achieve. This is how you come out. You can see these points, these things I just listed here. If you are doing it on a normal day, it can take you maybe a month. Anyway, it won't be just you. There will be a team doing this. So this is how you break down a data science problem, and these are some of the steps. Some might not necessarily follow these steps, but you have an idea of getting the problem and getting the solution. Right now we are in the middle of a pandemic all over the world. A lot of data are being generated. A lot of scientists are working. Researchers are working. Data scientists are also working. Do you agree? So in the midst of all this pandemic, they are using data to see if it can help in solving this problem. It may not be the solution, it may not be the drug, but using data to solve the problem can also be very very effective. So they work together with the researchers, the med labs and all that to come out with a product, to test the product. The testing stage is very important with a data scientist. Alright, so this brings me to the end of the presentation. So once again, do you have questions? Do you have areas that are not clear that you want me to lay emphasis on? Do you have things you might want to learn that you feel we could help? Just this is a time to open up, to pour out, and let me know why you want to go into the field. What do you want to achieve? What area do you want to play in, and all that? Because right now, I believe for you to be in this class, it means you have an interest for the topic I listed on social media, and for you to be here, it means you need to know, you want to know more. So if there's anything that has been confusing you over time that you want me to shed a little light on, you can raise your question now, then we reason together and we trash it out. So the floor is open now. Let's hear your questions. Okay, well explained. Alright. So thank you so much for your time. Thank you for your time. We hope you enjoyed the session. We upload the videos on the social media and send it to you. Once I'm done, then I think that will be the next thing. And if you have any question later, I'm always online. You can always buzz me on WhatsApp. If you don't have my WhatsApp, also let me know. So thank you so much, so much. I really appreciate your time, your coming. Have a wonderful day. This brings the meeting to an end. Bye for now.